Hare Krishna students, so in this video we'll solve this register network problem again but with a different symmetry. In the last video I had shown that how current symmetry works. Now in this video I'll tell you how the voltage symmetry works. You see it very carefully. Let us say we have connected this across a battery and this battery has different potentials obviously. So let us say I assume that the potential of this point is 0. So obviously this battery has a V potential, so this potential will become V. Now what I said is this, like as I told you in this last video, that there was same current in these three wires. So it means I will say from here that like there is same potential drop across these three wires AF, AC and AH. All these three have the same voltage drop. If they have the same voltage drop, let us say the voltage dropped by amount X. So I can say the potential here became V minus X. Similarly, the potential at H also became V minus X. And similarly, the potential here also became V minus X. Now, the next thing I said is this, that on this side also current is coming and symmetrically it is coming. In this resistance the current was going and symmetrically it was going, so it was going I by 3, I by 3 and I by 3. So similarly on this side also it is coming I by 3, I by 3, I by 3. So whatever was the drop in these resistance, the same drop should be in these resistance also. And here it is the lowest potential because current is reaching here, means G must have a potential greater than B. And how much it should be greater? It should be greater by X. Why I told it should be the value X? Because see, here the drop was I by 3 current was flowing, resistance R was there, V minus V minus X. So ultimately drop was X. Similarly, see here drop is also X. Understanding this symmetry. So with symmetry, I'll say the resist a potential of this point is also X and the potential of this point is also X. So ultimately what I got is that I got the potential of all these points. So now this what I'm going to draw is very important thing. Whenever you are able to get the potentials of these points in this method, now apply this trick. What I do is that I write the point potential V. Then here I will write what is the next potential V minus X. What is the next potential X and what is the last potential 0. Then what I say is that let us count how many resistance are between V and V minus X. This is the first one, then the second one and this is the third one. There are three resistance. So I said that there are three resistance which are in parallel like this because they all are between the same potentials V and V minus X. Now let us go to the next one. Then there are resistor between V minus X and X. How many are there? V minus X and X 1, V minus X and X 2, V minus X and X 3, V minus X and X 4, and I think how many we got? This is 1, then this is 2, then this is 3, then this is 4, then this is 5 and then this is 6. There are 6 resistance between V minus X and X. So I can show that there are 6 resistance between them and they all should be drawn like this. So I have drawn all of them. Now the last one is X and 0, X and 0 and X and 0. So how many there are? 3. So it became like this. Now what I can say, these 3 in parallel, these 6 in parallel, these 3 in parallel and overall they all go together in series. So what is the net value became? These 3 in parallel, when you will calculate students, so you will get this becomes R by 3, these became R by 6 and again those became R by 3. So on calculations, what we will get? We will get 5r by 6. And I think that is the same answer that we have got in our last video also. Okay, thank you. Hare Krishna.